Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. In this session, we are going to study the centroid of symmetrical sections. In the previous sessions, we have covered so far what is engineering mechanics, what are the types of engineering mechanics, and what is centroid. We have studied. Now here, the center of gravity, what is the center of gravity and the centroid, what are the terms between the centroid and center of gravity, we are going to study of various sections. So center of gravity of the point is the point through which all the forces, the whole weight of the body acts. Suppose your body is having only one center of gravity for all positions of the body, it is represented by, the center of gravity is represented by CZ, or simply it is G. So how can we know that? Here experimentally, theoretically, it is the whole weight of the body passing through the point. That point is known as center of gravity. Suppose there is an arbitrary section. How to find out the centroid or center of gravity of this, or the center of gravity of this section, plane, of this plane, or the centroid of this plane? Generally, the term the centroid is used for the plane sections, and the center of gravity is the term used for solid sections or the bodies or sections which is having some weight. Now, if we consider the plane section, the meaning, the centroid and center of gravity is having both the same meanings, but the difference is the application. The centroid, the term is used for plane sections, whereas the center of gravity of the term is used for cubical sections, or they are having sections which are having some weight. If you want to find out the certain weight of these arbitrary shapes, experimentally what to do? We have to hang this one on a certain point, and different points will pass through it. And at this point, we'll attach to a rope or thread which is attached to the rope, which is having some weight. That rope will hang down, this rope. Then we draw a line. Again, at various sections, if you hang this arbitrary shape, the line which is passing through that, this line will pass through, it is vertically downwards, it goes through it. The intersection of all these lines or rope lines, that point is known as the centroid of this sectional plane or area. If it is a solid body, it is the center of gravity of this section of this body. Now, the centroid is the point at which the total area of the plane figure, like the rectangle or square or circle or quadrilateral, etc., which passes through that point of a plane. So is assumed to be, what is the meaning? Concentrated. It is assumed to be concentrated, is known as the centroid of that area. Okay, now here the centroid, generally the meaning, both the terms, the center of gravity and centroid, is having the same meaning. So it is generally represented by CZ or simply Z. But the centroid and center of gravity are both the same points, at the same point. Alright. Now, what is the meaning of center of mass? What is the meaning of center of mass? Center means the point at which the total mass of your body is assumed to be concentrated. Total mass of your body is assumed to be concentrated. It is known as the center of mass. Your body is having only one center of mass for all positions of your body. Similarly, your body is having only one point of centroid. Each body is having only one centroid, one center of gravity. Okay, this is not number of more than one center of centroid and center of gravity. You should not be having. Okay, suppose if you are carrying a pen or a pencil or on the point, this is the point. It is completely balanced. That's why it is known as the centroid of this pen. Whatever you call it as a marker point. So it is balanced. Why? the support is at the centroid or the center of gravity. The support is at G of this body. That's why it is completely balanced. If this support is not passing through it is not at the centroid CG of the body, then it becomes unbalanced. Suppose you try to make it, yes, it's fallen down. Wow. That means why? It is not balancing because the support is not balanced. The support is balanced at the centroid, then it will be balanced. So here is the balancing point. Yes, completely balanced. Now the body will be balanced when the support is at the centroid at G point G. Otherwise, it will be unbalanced. Now here there are three terms we learned. Number one, center of gravity. And second term is the centroid. And the third one is center of mass. Center of mass. Now, what is the similarity between these three? The similarity is that the center of gravity means the weight of your body is passing through that point, is concentrated. The point at which the whole weight of the body is concentrated is known as center of gravity. Centroid. The whole area of the section is concentrated at a point is known as centroid. Center of mass, the point at which the total mass of the body is concentrated is known as center of mass. So the similarity is that it is the only point, but the application, these terms are applied. The centroid is applied to the sections, plane sections. Center of gravity is center of gravity and center of mass. Both are applied to having the bodies which are having certain mass and certain weight. But each body is having, whether it may be a plane or it may be a solid body, it is only one point. That point through which is only one centroid will be there, or one point of center of gravity and one point of center of mass. Is only one center of mass, one centroid, one center of gravity will be there each body. So the meaning is same. That's why it is denoted by either CG or simply G. Now let us see for the centroid of a plane, like a figures like a triangle, quadrilateral and circle, etc. in this section, having only areas but no mass. The areas, what is the area means? Plane, it is two-dimensional, it is not three-dimensional. The plane which is having only area but having no mass. The center of area of such figures is known as centroid. So the method of finding out the centroid of your figures is same as that of finding out the center of gravity of your body. So experimentally and theoretically, in this session we are going to study how to find out the centroid by theoretical method. Now here, different geometrical considerations we are going to consider, different geometries we are going to consider in order to find out the centroid of a figures, various figures such as triangle, quadrilateral, parallelogram, etc. Now here, the centroid or center of gravity, the CG of a uniform rod is where it will be at its middle point. And the center of gravity of a rectangle, rectangle or parallelogram is at the point where its diagonals meet each other. And it is also a middle point of the length as well as a breadth of the rectangle. Now here we'll see the figure it is. Suppose if you are considering a rectangle, if you join these diagonals, similarly if you join this diagonal, the diagonals meeting at one point, that point is known as the center of gravity. or and also if you consider the middle point, of the length and the midpoint of length is here, midpoints of the breadths, and join these two midpoints. Yes, this is also G point or a center of gravity. So it is for what? It is for a parallelogram or a rectangle. Suppose for the simple plane figures, if we consider it, just we can tell geometrically, the centroid of a uniform rod lies where it will be at its middle point. And the centroid or center of gravity of a triangle lies at the point where the three medians of the triangle meet. What is that meaning? Yeah, it's very simple. Three medians meet. If you consider the equilateral triangle or right angular triangle, join three medians. What are the medians are here? Median mean corner to at the midpoint of another opposite side. From this corner to this midpoint. From this corner to here, this midpoint. This is Z, center of gravity. And the center of gravity and the centroid of a rectangle, as we have studied before, by joining the diagonals and the midpoint, or another manner, the midpoint of the length and the midpoint of the breadths. If you join each other, as we have studied before here, it is for parallelogram and or rectangle. How to find out the centroid of a rectangle? And whatever the circle, generally the circle, if you consider the circle where it will be centroid. The centroid will be at its center. Very simple. So what is the use of the centroid calculations? Why should we go for it? Because these are applications of in order to apply our equilibrium forces or unbalancing forces to maintain the balancing of structures. We need the centroid or center of gravity points of a structure or of a components, such a way that the body will be in completely balanced. Body will be in balanced completely. Otherwise, because of this unbalancing forces, what will happen? The vibrations will begin. That vibration causes damage to the structure. So when these cyclic loads are acting, when the body is always under some cyclic loads, when the structure is passing through some certain cyclic loads, these unbalanced forces causes severe vibrations, leads to damage of the structure. In order to avoid this failure, we need the calculations of the centroid of various cross sections. Here it is simple, the single geometry, simple figures, rectangle, triangle, or square parallelogram we considered here. Suppose the cross section of a beam, it can be a T section or it can be a I section. It is a T section and it can be a I section, the beams. In order to maintain, we have to find out this type of I section and a T section centroids. Then, through which, when the body or when a new force is passing through it, we'll study in future in coming sessions. So that's why we have to find out the centroid or center of gravity of the figures of various sections. Now here, we studied here what is the rectangle, centroid of a rectangle, centroid of a triangle, equilateral triangle, and the centroid of a circle. Or suppose if we consider the centroid of a right angled triangle, If you consider the centroid of a right angle triangle, yeah, it is a right angle triangle. How to find out the centroid of a right angle triangle? Yes, join the median, three medians meeting each other, then it will be at one point. Yes. This is known as the centroid of right angle triangle. Thus, we have to find out for a simple plane figures, centroids for a simple plane figures. Coming to the centroid, what is the denoted by? How the centroid is denoted by? It is, suppose if we consider a rectangle, the reference axis will be, there are two reference axes. One is axis X, another one is axis Y. So, it is the point through which, what is the distance of a rectangle? The base is having the B and H is the height. With the reference to x-axis, what is the central distance here? It is H by 2, half of H. If the reference to y-axis, what is the centroid? That is B by 2, half. So, there are two coordinates are required in order to find out the point of a plane figure. That is a bar X and a bar Y. These are the coordinates of this bar X and bar Y, represents the location of a centroid of a body. What is the bar X here? It is the centroidal position. What is the bar X? There is the horizontal distance, that is a B by 2. What is bar Y? That is a H by 2. This is the bar X and a bar Y. So, in some of the textbooks, it is followed by X dot and Y dot. But most of the reference is followed by bar X and a bar Y. Alright? Is the bar X and here it is bar Y. So, for rectangle, the shape of a rectangle, it is, area is base into height and bar X is B by 2 and H by 2. Suppose, very important here, that both X and Y axis are passing through centroidal distance, passing through this centroid point. Now, what is bar X and bar Y? Now, these are the reference axes. What is the bar X and bar Y? For that condition, bar X and bar Y is 0, 0. That means, these axes, X and Y axis are passing through the centroidal point of a rectangle. That's why it is 0, 0. Suppose, if you consider it, I consider it is a rectangle, is having base B and height H. Alright. My axes are somewhere else, some distance, it is the x-axis. Now, it is a point, the point from here to here it is, this distance is H by 2. And this distance from reference to the surface B base to this axis is some P. What is the centroidal, that is the bar Y from this reference axis XX of a rectangle? That is bar Y equal to, what is bar Y equal to? P plus H by 2. P plus H by 2. We have to know it, what is the reference axis and what is the location of the point centroid. Alright. From this reference axis XS, the centroidal distance of this rectangle is P plus H by 2. Similarly, suppose if this axis, reference axis passing through the centroidal distance of this rectangular section, then bar x and bar y is 0, 0. And if you consider the bar x distance here, the reference axis is at the base and y reference axis at the adjacent side, that is the here h height distance. Then what is the bar x is h by bar x is b by 2, bar y is h by 2. Okay. Now similarly, now we are going to triangle. Where is the reference axis? One has to know it. Yeah, it is a triangle. We consider here triangle. The bar y is part of here. The bar y location is the reference axis y location is passing through the centroid point from apex, and the reference axis of x is the base b. What is the area of the triangle? That is of base into height. What is the bar x? The bar x means x bar horizontal distance from reference axis y. What is the horizontal distance here? It is passing through centroidal, that's why 0. Whatever bar y distance, what is the bar y means? It is the reference axis, the distance from xx to the centroidal distance. The xx to centroidal distance, that is h by 3. So what is bar x and bar y? Centroidal point, bar x and bar y of a triangle is bar x is 0, bar y is h by 3. Now coming to the circle. The circle distance, what is the circle here? It is a circle. The circle is having a radius r, where it is location. The bar x and bar y, where it is. The bar x is passing through the axis, reference axis. X is passing through central distance and y is passing through centroidal. So what is bar x and bar y? 0, 0. Suppose for a circle, if you consider it, all of you pay attention. Here it is, circle. I consider the circle. The reference axis xx, here it is, and the reference axis yy. This is central distance. What is radius? The radius is r. What is the centroidal distance for this section? Bar x and bar y. What is the bar x? This is the horizontal distance from vertical axis, that is the y. What is the distance here from here to here? That is r. What is the distance from, what is the bar y distance? That is from vertical distance from horizontal axis. This is r. So, thus, we have to know the basics. Where is the location of the reference axis and what is the bar x and bar y. So, let us again recapitulating some of the points. Rectangle, the reference axis at a b and y, that is at a h sides, vertical side. And for the triangle, y-axis is passing to the centroid point, and bar x is at a b. Coming to the circle, in this case, bar x and y are passing through the centroid. That's why when x and y reference axis are passing to the centroid point, then the centroid distance, what is the centroid distance, is passing to the same point. That's why 0, 0. There is no distance. If in this case, the distance, the reference axis xx and yy, it is on the surface. That's why what is the bar x and bar y? It is radius of the circle, that is r, r. Okay, these are the various types of sections which we are rectangular areas. For consider here the rectangular area. In this case here it is A is the height, B is the base. So bar x and bar y. What is the bar x comma bar y? This is the reference axis. If you consider it, that is b by 2 comma a by 2. Okay. Similarly, what is the area of this rectangular area? A times b, AB. For the triangle, what is the bar x and bar y for this triangle? What is the for triangle? What is the distance? That is b plus 2a by 3 comma h by 3. From this slide you can understand the centroidal distances of various cross sections or various sections. So here we have studied here the various sections. We are seeing the bar x and bar y for rectangle b by 2 comma a by 2 for this triangular area, that is of base times h into a plus b, and whereas for trapezoidal area, what is bar y and bar y, this is the bar x and it is the portion is bar y, and whereas the circle passing to the centroid, bar x and bar y 0 0, provided the reference axes are passing to the centroid. And here it is the semicircular area. The semicircular area, if you passing through it, that is what about here, the semicircle, bar x and bar y. The bar x distance, if the reference axis is here x and here it is y, bar x equal to r. What about bar y? That is 4r by 3 pi. Okay, quarter circle, the quarter circle area, both bar x and bar y, 4r by 3 pi and 4r by 3 pi. If you consider the circular sector, whatever bar x, here bar y is passing through, the bar x is passing through the centroidal distance. So bar y equal to 0 and bar x equal to 2r times sine theta by 3 theta. Okay, what about theta? That is what is the units for theta? Here sine theta is in degrees here. Okay, now what about the elliptical area? Provided here the elliptical area of elliptical cross section is pi AB. Similarly, semi-elliptical area, whatever bar x equal to a, bar y equal to 4b by 3 pi. Quarter elliptical area, that is 4b by 3 pi, 4a by 3 pi and 4b by 3 pi. The centroid is here is the centroid. The centroid of a general spandrel, what is the centroid of a general spandrel? It is bar x equal to n plus 1 by n plus 2 times b, bar y equal to n plus 1 by 4n plus 2 times b. Now, this is the location centroid of a rectangle, this is the triangle centroid, the trapezoidal area centroid, and here the circular centroid. For this semicircular area, centroidal distance. For quarter circular area, the location, this is the central point. Whereas for circular sector, the centroid distance is C here. Whereas for elliptical, centroidal distance, here it is the semi-elliptical area, quarter elliptical area, and finally general spandrel, that is the centroidal distance. So there are total 11 cross sections and centroidal we have observed here. So these are the simple plane figures, centroidal distance. Now practically, okay, we have to find out the centroid of a solid of composite figures, of composite bodies, different cross section bodies. It is having at the various cross sections and various geometries. If they are attached as a single object, then what is the center of gravity for that body? For that, we are understanding these are the basics. These are the simple plane figures. Now, if 2-3 rectangles are joined in such a way that what is the centroid? This is one rectangle and here it is another rectangle, and another rectangle you kept vertically, then it becomes what? If you join these three, it is known as the I-section. This type of figures is known as composite figures. The various cross sections are joined. Alright. So how to find out the centroid of such figures? Okay. Now let us begin. What is symmetrical sections and what is the unsymmetrical sections? Now in this figure, if we consider the line, it is symmetrical about, what is the symmetry? You fold vertically about vertical axis and unfold it. If you see both sides are same, the left side and for your side, from my side, the left side, this side and this side both are same. That means it is symmetrical about vertical axis, that is axis Y. Similarly, if you fold horizontally, the line figure, if you fold horizontally, if you fold it horizontally, can you find out that above line and below line are having same geometry? No. That's why it is unsymmetrical about x-axis and symmetrical about vertical axis. It is symmetrical about vertical axis or y-axis and unsymmetrical about horizontal axis. That means x-axis unsymmetrical about it is symmetrical about vertical axis, y-axis. Now coming to different cross-section in nature, it is available if you carefully observe it. Now if you consider here, this is the figure is having, butterfly is having is the symmetrical about vertical axis. It is symmetrical about vertical axis. Another one, the leaf you consider is symmetrical about vertical axis. If you consider the bug, it is symmetrical about vertical axis. Similarly, our faces is also symmetry about vertical axis. If it is unsymmetry, then in the case of human beings, we consider them as a handicap. It's not beautiful, it looks ugly. Alright. Now, these are the coming to lines of symmetry. These are the various lines of symmetry. In the square line is the 4 lines of symmetry, whereas rectangle is 2 lines of symmetry, rhombus 2 lines of symmetry, and the kite is having 1 line of symmetry, that is the vertical axis, and 1 line of symmetry is the isosceles trapezoid, and this trapezoid having, there is no lines of symmetry, that means unsymmetrical. The parallelogram, yes, it is unsymmetrical, yes, okay. And the equilateral triangle is the 3 lines of symmetry, and finally isosceles triangle is having 1 line of symmetry. The point is that here we have seen the lines of symmetries of single line, 4 lines of symmetries, and unsymmetrical sections. There is no symmetrical about any axis, any line, neither vertical nor horizontal lines. So these are the concepts we have studied. What is symmetry? What is centroid? What is the difference in definition point of view or in concept point of view between, what is the difference between center of gravity, centroid and center of mass, and how to calculate centroids of a simple plane figures. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.